tree looks like.
What was that? That was 3 million.
Alright, ignore that last part. Time is the enemy. That's silly. Time is amazing. Alright. Oh, I gotta get out of the way.
That's what I just said.
Alright, so. Yeah. Alright, guys, so that was pretty crazy, right?
One light. Oh, please, Miss Nan. Thank you. Oh, vampire.
When did those things happen in Austin?
One of them happened in Austin.
One of them happened in Austin? Yeah. You know, Austin's a neat territory in the country. It's pretty neat because it's actually relatively safe here. I mean, we do get severe weather. We're getting into the severe weather seasons coming up soon, and that what you saw yesterday, we're probably going to see more of. But really, that's about it. We get earthquakes here, but it's not bad at all. You know, if we get a hurricane, it's once in a blue moon, right? They usually go to our east. Snow, we don't get much of. So, I mean, we get a lot of sunshine. The weather's pretty mild and calm. But there are places that, you know, get a lot of it, like Florida. They're getting tons of that stuff. I mean, the thing we need to worry about here a lot is, of course, flooding. When we get a lot of rain, you know, all that water rises, so that gets dangerous. But other than that, it's pretty quiet. You got a question?
What would happen if 2 tornadoes got put together?
You know what? That's really hard to happen. You can get 2 tornadoes stemming off of the same cell, but having them come together is kind of hard because it's like putting the ends of 2 magnets together that opposite. They kind of push away from each other and they do their own thing. I mean, if you were to get 2 individual tornadoes to like spawn like this, and then a bigger storm were to come in and take it all in, it could grab it and kind of turn it together, but it would just be a big tornado. So, can I put this thing up? You know how to do it. Oh. Awesome. All right. Let's see. Do we have pens? Yeah, there's one right here.
Selfish.
Okay, so a couple things I want to talk about. You guys can see this here. What do you guys know about the weather so far? Kind of raise your hand and let me know what you guys understand. Clouding, like names of them, or just clouds. Okay.
Rain.
Kind of rainy in the morning.
Rain. You know a little bit about rain. Okay. Yeah, totally. You over here in the pink.
Oh, it gets really humid after it rains.
Yeah. Okay. And do you know why?
Because all the evaporation.
Okay. What do you have an answer? That's right. That's a great answer.
I was gonna.
Yeah. All right. So there are a couple things about Texas that make it interesting. Okay. I'm gonna draw. Don't make fun of my drawing, please. I'm very self-conscious. No, I'm just kidding.
Very self-conscious.
SCUS?
Yeah.
Yeah, I see what. That's actually pretty good.
Right? So the thing about Texas is you got this big body of warm water, right?
Yeah.
Everyone always asks, why doesn't it snow in Austin? Why don't we get snow?
Oh, I know the answer.
We want snow. What's the answer?
Because we're too close to the equator.
We're very close to the equator, but you know what? There's places, I guess we're about here. There's places down here in Mexico that get snow.
What?
Mm-hmm.
They're really tall mountains. So you gotta think about snow, right?
Oh, I know one.
You need temperatures to be 32 degrees in order for snow to form. And you gotta think about the sky as a big cake. It's got multiple layers, right? You start off with the frosting, and then you got some breading, and then you got more frosting, and then some more breading, and then at the bottom you got Skittles or whatever you want to put on. Yeah, that's kind of weird, but. And so when you think about it like that, you gotta have 32 degrees from top to bottom. And for us, it's too hard to happen. We get 32 degrees up there all the time and below, but down here, we get these winds that come out of the south and southeast. Like this morning, you stepped outside, and you probably didn't even need a coat, right? It was like 70 degrees out. What? It did look cold, but it wasn't cold, right? No, it was super warm. That's because when the winds come on, I mean, this body of water down here stays like a jacuzzi almost year-round. I mean, it cools down a little bit, but really, temperatures in the heart of the Gulf of Mexico do not get below 70 degrees. And so it stays warm. So whenever the wind comes from this way, it warms up. It's super warm. So what we need is, obviously, you've got these mountain ranges right here, right? And then you got these mountain ranges right here. So these are the Cascades, and then you have the Sierra Mountains. Then you've got the Rocky Mountains right here. So a good chunk of the western U.S. is high in elevation, so they're getting a lot of snow. Plus, they're higher in latitude. So you get up here towards the poles, and it's cold. Down here in the equator, it's warm. What the Earth, what it ultimately wants to do, what Mother Nature wants to do with the globe, is it wants to take the warm air at the equator and push it upward. It wants to take the cold air at the poles and pull it downward and mix it up so it's all equal. So that's why we're getting these storms. Because if you think of a big hurricane that's developing down here, what? Hurricanes moving this way, right? And then which way do they go? They go up, right? You ever see a track? They'll usually come over, they'll come into Florida. Here's Katrina's track. It went right in here, and then it went up like this. And went that way, because it's taking all this warm air in the equator regions, and it's distributing it northward. So if you were to bring all this up here, it's going to be really warm up here near the storm, because it's taking all that warm water and moving northward. You get these big polar lows, right? We have a, over here by Alaska, we've got these islands that come out like this. Let's say this is Alaska, right? It's not a good drawing, but there's these islands out here. Anyone know what those are called? What'd you say? The what? No, not the Virgin Islands. The Aleutian Islands. So what happens over here is water temperatures are like 36 degrees Fahrenheit, right? It's cold. But the land is like -50 at times. So compared to these temperatures, this is actually warm. So you have this big contrast in temperatures. When you get big contrasts like that, you get storm development. And so what happens is we have this low pressure system that always forms right here, all the time. It's going to form right here by Alaska. It's going to get caught in the jet stream. It's going to decide it's either going to come up in Oregon and then Washington and then come back down and then move this way. It's either going to dip down like this last storm went like this, came all the way down, was throwing up snow over here, rain along California coast, came down over here, and then it went up like this.
Pretty much your time.
Yeah, and you know what? It brought a lot of cold air with it. So that Mother Nature was like, okay, the cold air needs to come down here, the warm air needs to go up there, let's try to distribute it and get it equal. So what's happening is this storm, what we need in order to get snow, is you need to have this storm, but not have these winds. And it's really hard to do that because, does anybody know which way wind flows around a low pressure system? Have you guys learned about low pressure systems and high pressure systems?
Yes.
A little bit?
A little bit.
Give me the general idea. What is high pressure? What does it do?
Oh.
Yeah.
I think it makes stuff hotter.
Good answer. Do you know? Okay, generally you could say that, but not necessarily. What it does is it adds to downward motion, right? So the air is moving down, so you can't have clouds forming. And usually when that happens, you have a lot more sun, so then it warms up. So that technically you're kind of right. With low pressure, it's the opposite. It's like turning a fan on and standing behind it and all the air is sucking into the fan. It's like this system, it rotates like this. Counterclockwise. And you get all the air going towards it. High pressure, which usually sits like right here, which goes clockwise. So we get that flow of south winds coming up like this. So when this comes down here, you've got spinning and spinning, and it's really, really hard to get a north wind. If we were to get a north wind, we'd see snow, but that's why we never do. But you know what? You get like right up here, like storm system a month ago came, and up in Dallas, they saw like 4 inches of snow, and we were getting just rain. They had enough cold air that was just pooling up here that it could create snow. So that, I mean, a lot of kids ask that, like, when's it gonna snow? We want a snow day. And it's just, you know, it's too hard to happen in Austin. But with this high pressure here, we stay mild. You know, we do get darn hot in the summer. But like right now, it's pretty nice, right? It's pretty cool. So that's kind of like the idea of some of the things we get coming up. Obviously, in spring, you've got this storm system, same pattern, okay? Low pressure starting up here. High pressure usually down here. This thing's going to come. It's going to swing like this, right? You have warm Gulf moisture coming in right here, cold Pacific moisture coming in right here, meeting right there. What's that called? That area, part of the country. Does anybody know what that's called?
Tornado. Oh, tornado.
Tornado Alley.
Yeah, that's exactly right. Tornado Alley.
Oh yeah.
So you got a Twister.
No, I watched the movie
Like a documentary?
Yeah.
It's pretty cool, man. They got awesome videos, and you can just go on YouTube and look at some crazy footage. And you get the combination of this cold air and warm air colliding. And again, it's Mother Nature trying to get rid of the heat, but you get those two combining, and they just don't like each other. And they spin up, and that's why you get that tapping right there. I mean, we get tornadoes here too. You know, we got to keep an eye out for that. Just not as much as they do, like in Lubbock or Amarillo, up there in the Panhandle of Texas, because it gets pretty bad. You guys have any questions so far? Yeah.
A long time ago, I don't know how many years ago, there was a tornado in Bozeman, Montana,
Yeah.
and our family was in Belgrade, so we were in,
When was this? How long ago?
I don't know,
A couple years ago?
a few more.
I remember I used to work up in Washington, and there was a tornado in Bozeman. They got on a camera on top of one of their buildings, and I remember looking at it. But it might have been the same one, it might not have been. Yeah?
How are tornadoes formed?
It's so complicated. But let's break it down, shall we? Do we have an eraser? If not, no big deal. I got my hand.
I got Kleenex if nothing else.
Hands are
Here you go.
They're what?
hands are terrible when you wipe.
I know.
Put it
Your hands are great though. Come here. No, I'm just kidding.
I would totally do that.
I'm just
You gotta remember we had budget cuts last year.
Oh, I know.
We did
Dude,
raise
it's
it.
a station too.
Yeah, it's all lovely.
You've got a Kleenex.
All right, so remember how I was telling you, think about the sky in layers like a cake with Skittles? Kind of weird. Okay, so you've got the ground here. There's a tree, just so you know that's the ground.
And
Here's me.
It's
I'm just as tall as the tree. It's a small tree. Okay, so you got the sky. Let's say this is the top of the world, right? Here's a fun fact.
Uh-oh. Yay.
50% of the atmosphere, it's kind of weird, it doesn't look like it, is down here. The other 50% is up here.
whoa.
Isn't that funny?
That is fun.
That doesn't make sense.
I know it doesn't make sense at all. But you've got different layers of the atmosphere. I mean, we can get into that. There's a cool graphic right here. Yeah, it's small. But you got the tropopause, you got the stratosphere. What does that say? Mesopause? Mesosphere. Okay, you got these different layers, the thermosphere. So what happens is up towards the top, you got like just space colliding with Earth, and there's like no air molecules up there. And then down here, you got a little bit of air molecules, but you notice when you fly in a plane, you're above the clouds, right?
Yeah.
Because the clouds are only forming down where there's where there's part of the atmosphere for it to form. Up here, there's just not enough space, and so it's like the same amount of molecules are here that are here. They're just spread out. These are condensed, spread out. So let's just break down. Okay. So let's say these are individual, like, streaks in the sky, different layers. Okay. You got your clouds. You know, your birds. And what happens with tornadoes, remember that graphic, the warm air and the cold air colliding, right? So what's happening here is you're getting big cloud formations, you know, lots of that warm air getting pulled up. Okay, you got hail and stuff up in here and it's pulling down some rain. But also what's happening in these different layers is so many different things. You got wind going up here, you got wind going sideways and this way and coming down, and there's a lot of turning. And so what happens in some of these layers is you get like a vortex. You get a tornado in the sky that's spinning like this. Okay? And it's there, you know, if you guys ever go to study weather, you know, there's been people who have studied tornadoes their whole lives, and there's still so many things we don't know about them. We know a limited amount. We know we can get people advance notice by about 5-10 minutes. They can get into a shelter. We know when the atmosphere is ripe enough. But what happens is you get all this collision taking place, and you get this vortex to spin. And then what happens is you get a big updraft moving from down up, like one of these clouds moving over here, and you get a big vacuum happening. And when that happens, it pushes that vortex up, and the bottom end of that vortex comes down. And so this vortex comes out like that. And then boom, there's your tornado. So sometimes you'll see tornadoes like angling. That's because one side's pushing it up, and the other's pushing it down. If that didn't happen, it would just stay up in the sky and you'd be fine. And sometimes you push down, and it won't touch the ground all the way, so it's called a funnel cloud. It'll be close. So, interesting, right? It's kind of different. You guys can watch the Weather Channel, and they try to explain it the best they can. They do a really good job when they're on TV. But you know, there's people out chasing and trying to warn people. You know, they're really cool to look at, and they really are, but they're so dangerous. Nowadays, there's so many storm chasers out there. You can go on History Channel and you see storm chasing videos, and there's people who are like grabbing their iPhones and they're like, I'm gonna go chase this tornado and take a video of it and I'm gonna get paid for it. And then they get pulled up because what the meteorologists, they've got the radar, they know where the storm's moving. Joe Blow is gonna go and he's not gonna know, and he's gonna be in the wrong place at the wrong time. So you gotta be careful like that. Yeah.
We saw storm chasers once, and they were in a tornado, and they were showing it live for like the first time, and they were like doing this thing where they were in the car and they were getting really close to the tornado. My dad was like, they're getting awfully close, and then they were like, whoa, we're getting pulled off the ground, and then you could just see something go boom, and then the camera was out.
Is that real?
Yeah.
Really?
Live.
Oh my gosh, it's like a movie. Did you just change the channel?
There's actually a movie on tornadoes.
Oh, totally. I know. I've seen a bunch of them. They're really cool.
Yeah.
See, I've never actually seen one.
Really?
I've never seen one in person, but you know, I try to keep an eye on the radar and keep people informed on when it's going to happen. You gotta get a good turning of wind. That southeast wind I was telling you about with that low pressure system, and it can happen, especially in a couple months.
And I think last year, my sister's best friend in Houston, she said there was a tornado watch.
Yeah. We had one here a couple weeks ago up in Williamson. Are we in Williamson County? Yeah, we are in Williamson County. Are we?
Yes.
It's so mind your manners.
Are we in Williamson County?
We are in Huddle, which is
Yeah.
So we had one in this county a couple weeks ago, but it didn't. They shouldn't have issued one, but they did. Yeah.
Last year, me and this guy, and we went on a field trip and we watched Tornado Alley.
Yeah, we did too.
What do you mean you watched Tornado Alley? You went and watched a movie called Tornado Alley, or you went out to Tornado Alley?
No.
Oh,
And watch.
It's like
in a big theater.
yeah, that's cool. That's really cool. You know, you guys, this weekend, you guys should take note of this too. Weatherfest is this weekend at the State Texas something museum. Yeah. There was a Weatherfest. They've got a storm chasing machine there.
Yeah, I went there last year at my school,
Yeah.
and we watched this thing.
They got videos. They got so many cool toys. It's going to be tomorrow, and it's going to be a lot of fun if you guys want to go. What time is it? What else do you guys want to learn about? How much time do we have? 15 minutes. You guys want to learn about anything specific? Do you have any questions about my job, about anything? I can go and teach you about hail. I mean, I can teach you about different clouds. I can teach you about whatever you want.
Because you know how y'all have the green screen?
Yeah.
How do y'all know what to do?
Like I said, you just look at the TV, and it takes practice. So like the first time I was on TV, I definitely did not point in the right direction. And you have to make sure when you're on camera that you're standing in the right spot, so things aren't coming like off your head and stuff. Like if you're standing, and I have an arrow drawn, and I'm standing right in front of it, and it's like pointing to my head. You gotta make sure you're kind of like off, so it doesn't look weird, or like I have things growing out of my ear. Yeah. So the big sail was, you saw in the video. I mean, you got hail about this big. So the thing about hail too, a lot of people say, hail is similar to snow, right? It is similar, but it's made completely different. So this is the layers that, okay, the ground is down here, and the cloud is right here. It's probably like negative 35 degrees in here. It's creating snow. You've got temperature right here at 0 degrees Fahrenheit. You got temperature right here at 28 degrees Fahrenheit, and then down here at the surface you have temperatures at like 39 degrees Fahrenheit. So you're going to get snow, 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 and then what happens here?
Hail.
Rain. It melts. It just melts and turns into rain.
Oh yeah, because the air gets hotter.
Yeah, it gets too warm. If you take a snowflake and melt it, it's just going to turn into liquid. It doesn't turn into hail. And then here's another quiz. Okay, so here's a cloud. What? Say it.
I thought we were in science club.
We're not in class, we're in a club.
It's not a quiz. It's more like I'm teaching you how this works. It's pretty cool. It's not a quiz. It's more. Okay, Mr. Smart Pants. What do you got here? Snow or rain?
Snow.
Snow, right? Because it's below 32. What about here?
Snow.
Snow, because it's below 32. What about here?
Rain.
Rain, because it's above 32. What about here?
Hail.
We go
No.
Hail.
we go to negative 24.
Hail.
It's actually ice. Freezing rain, sleet, grapple, different terms that mean different things. But what happens when you take an ice tray and put it in your freezer?
It freezes.
It freezes, right? You can't take water and turn it into snow. Water just turns into ice. So then it goes into ice, and then it falls as freezing rain, and then you get, an ice rink on the ground. With hail, okay, you hail guys and gals? Hail's like this. Anyone know what this cloud is called?
Cumulus. Cumulus.
Yes, you guys are all right. Cumulus, and if it's raining, cumulonimbus. Nimbus is the term of rain. So you could have stratonimbus, you could have cumulonimbus, nimbus I guess I said it wrong, nimbus stratus. So it's a type of cumuliform, alright? So, remember what I said? It's like a vacuum, and you guys have wind coming up, pulling up into the cloud. Up into the cloud, you have freezing temperatures, and you have a bunch of little microbes and raindrops and a bunch of stuff up in there. And what happens is you get all that wind to come up, and all of these are colliding with each other, and they're trying, once they get big enough to form rain, it wants to fall to the surface because of gravity, right? Once it's heavy enough and it can't float anymore, it's going to come down because gravity's going to pull it down. But it can't go down because this wind is too strong. Okay?
Oh, I know.
Down. Yeah.
I know what happens next.
What happens next?
Okay, so it keeps going up and down and up and down, and it just builds up.
That's exactly right. Yeah, it keeps going up and down, and as long as this wind just keep pushing it up, and it's so cold up here, it freezes and turns into hail. Now, if it's powerful enough, and that updraft is super windy, the hail will just grow until it's too heavy to stay up anymore and it just falls.